Alright, welcome back to PA Academy. So this is the continuation to the previous video on that example 2. So where I said I'm going to explain how do you determine, let me go back to that question. So if you are asked to look for RAB, why are we subtracting the value of B from A and not A from B? Exactly. So like I said, I was going to explain it. So before I get into that explanation, in the previous example I did as previous example, I forgot to add the unit for the vector force, so which is Newton. So the reason why I need to mention is it's very important to always add your unit to all the calculation. So I forgot to add it while doing that particular video. So again, don't forget, always add your unit. So in example 1, I added the unit. You can see it here is in units. So example 2, in that video I didn't add it. So take note of that. So now let's go to the main part of this video. Now let me draw this diagram. If this part is the origin, exactly, and then we have a straight line like this. And then let's take note of those points. And then from the origin to this point and then to here. So let's take this place to be our Q1 and this place to be our Q2. Exactly. So we have, let's say there's a force acting towards this direction. Let's call it F12. And then towards this direction, let's call it F21. So like I said, this is the origin. So so if this is R, so that means it will be R1, and then this will be R2. All right. Now for us to get the vector from this point to this point, from the resultant of from Q1 to Q2, exactly. So, and it's also in this direction now. It's also important. The direction is also important. So that means we are coming from Q1 to Q2. So that means the resultant vector will be R12. Are we good? Now for you to get that R12, so that means R12 will definitely be R2 minus R1. This is negative sign. So R2 minus R1. Also, by virtue of this position, this direction like this, it's letting you that Q1 is exacting a force on Q2. That's this Q1 is exacting a force on Q2. So now let's go back to the question, some of the questions that we've looked at in the past. So he said, find the force exerted on QB by QA. So this Q2, we can also take it to be our QB, and this, we can also take this to be our QA. So QA, and it's also, let's just put equals to. So just like the question said, I find the force exerted on QB by QA. That means a particular force is also coming from QA, exerting it on QB. So once you see something like that, just know that if you are to get your unit vector, which is your R12, so that means our R12 can also be equals to RAB. So that means it's just going to be the force that is being acted upon, which is R2, which is this one, minus the one that is acting on the force that is being acted upon by the one that is acting. So that will be R. So this should be R. The 2 should be in subscript. So R2 minus R1. So I hope you are getting the picture now. So if you also go back to the first example that we did. So in the first example that we did, where the question says, all right, says find the force exerted in Q2 by Q1. Exactly, in Q2 by Q1. So what you just need to take note of is the force is being exerted in Q2 by Q1. So that means if this is the line of force, and if this point here is our Q1, and if this point here is our Q2, exactly, and we have an origin somewhere here. Yeah, so that means if the force being exerted in Q2 by Q1, so that means the direction is coming like this. Exactly. So once the direction is coming like this, then our unit vector, which is or the resultant vector, whichever way you want to call it, or whichever way you understand it, will be R12. Exactly. And then when it is R12, so this is, so if this is the origin, so that means like just like I explained here, so from here to here is our R2, because it's from the origin towards the charge on 2, and this place is our R1, which is the charge on 1. So that means our R12 is nothing but R2 minus R1. So it's just like I'm explaining it again, R2 minus R1. So it is the one that is being acted upon minus one that is acting. Exactly. So just take note of that. So that is why the subtraction is always like that. Exactly. It's just like the opposite of how it is being written. So going back here where we have this to be, where did I write it? Okay, so where we have this to be our R1 and we have this to be our R2. Exactly. And when we are looking for R12, we subtracted R2 from R1, which is 2 minus 1 like we have here, 0 minus 2 like we have here, then 5 minus 3 like we have here. Exactly. And again, the reason why we are having it as R12 is what I've also explained then. It said the force that is exacted on R2 by R1, so the force that is exacted on R2 by R1, so that means from R2 towards R1, and that's the direction of the arrow. Exactly. So if the question is saying, if this is our Q1 and this is our Q2, if the question is saying that the force that is being acted upon Q1 by Q2, or acted, sometimes you can say acted on Q1, that's English, acted on Q1 or in Q1 by or from Q2. So the direction is like this. Exactly. So that means this time around we are going to be having our R21 by virtue of this. Then let's introduce the origin. So this will be our R1 and this will be our R2. So our R21, unit vector R21 will definitely be R1, so not capital R. That will be R1 minus R2. And that small r is the one that they will give you in vector form. So where your R1 can be a set of number 2, 4, 6, this will be our X, our Y, and our Z coordinates. Then our R2, let's just give some random numbers, 1, 2, 3. So this will also be your X, your Y, and then your Z. So if it is this now, which is R21, then to be R1 minus R2. So definitely this will now be 2 minus 1 AX plus 4 minus 2 AY. Exactly. So the reason I'm going through this is so that you can understand the concept. It's not magic, it's not Sakamanji. So just try to understand it and I believe you'll be fine. So if you find this helpful, if you find this explanation helpful, just let me know. And if you have any doubt, just let me know in the comment section and then I'll just do my best to attend to it. So thank you very much and then I'll see you all in another video.